your spring homework 25, review graphing logs and properties of logs. Okay, so let's start with this one. So there's a log, and there's a plus sign. So this is product rule. So that means when you guys condense it, there's just going to be one logarithm. Now remember, it's this one times this one. So x times x is x squared. X times 16 is plus 16x. All of that is in parentheses, and that's all equal to 2. Now, you guys are going to use your log to exponential form. So you guys are going to get 6 to the second power is equal to x squared plus 16x. Moving this over here. 36 is equal to x squared plus 16x. Subtract 36 from both sides. So we're going to get 0 is equal to x squared plus 16x minus 36. Then you guys factor this, and the factors will be x plus 18 and x minus 2. So then your x's are going to be negative 18 and 2. Now remember, you have to plug these into the original to see. Now, do you guys notice that when you plug in negative 18 into here, you are going to have a negative log. So that's not allowed. So this cannot be an answer. Ooh. This cannot be an answer, so your only answer is x is equal to 2. Over here. Alright, so log, and there's a minus sign, so then this is your guys' quotient rule, which is also in your notes. So it'll just be 1 log in parentheses this divided by this. X minus 2 all divided by 2 is equal to, oh sorry, all divided by x. And now you guys just change this from log form to exponential. So 5 to the second is equal to x minus 2 over x. 25 is equal to x minus 2 over x. So let's get rid of this x at the bottom. Let's multiply both sides by x's. These cancel. So we're going to get 25x is equal to x minus 2. Solve for x now. So subtract x to both sides. 24x is equal to negative 2. Divide both sides by 24. X is equal to negative 2 over 24. And when you guys simplify this, divide top and bottom by 2. So x is going to equal to negative 1 over 12. And notice, you guys, if you plug this negative into here or into here, notice that you're going to get negatives in the inside. So this is going to be no solution. Number 3, log plus sign, so it's product rule. So log base 3 of this times this. 8 times 2x squared, you guys, is 16x squared. Now change from log form to exponential, so 3 to the second is equal to 16x squared. 9 is equal to 16x squared. Divide both sides by 16. And we're going to get 9 over 16 is equal to x squared. Square root both sides, and remember you get plus or minus. So plus and minus, the square root of 9 is 3, the square root of 16 is 4, is equal to x. And if we plug both of those into the original, they seem to be good. So this is going to be your guys' answer. Number 4, log and a plus sign. So this is product rule. So log base 4 of this times this. X times x is x squared. X times 2 is 2x. Now look on the other side, you guys. You get log base of 4. This is the type of problem, you guys, remember, if you have a log and a log, then all you have to do is equate this one to that one. So x squared plus 2x is equal to 3. Subtract 3 from both sides. X squared plus 2x minus 3 is equal to 0. Factor, and we get x plus 3, and x minus 1 is equal to 0. So x is equal to negative 3 and 1. Now, if you guys plug in negative 3 and 1 into here, notice if you plug negative 3 into here, that whole thing's going to be negative. So negative 3 cannot be a answer. So your only answer is x is equal to 1. 5, log log, and a minus sign, so quotient rule. So log base 2 log base 2 of this divided by that. So x squared plus 9 all divided by 5 is equal to 1. Now let's get this from log form to exponential. So we're going to get 2 to the 1 is equal to x squared plus 9 all over 5. So I'm just going to put that 2 over 1, you guys, because let's multiply both sides by 5. Because these cancel. So 2 times 5 is 10. X squared plus 9. Subtract 9 of both sides. 1 is equal to x squared. Square root both sides. Plus or minus 1 is equal to x. Make sure when you plug in 1 or negative 1, it's good. It is. So this is your answer. Number 6. Log log plus, so it's product rule. So log base 2 of this times that. 3x times 6, you guys, is 18x. That's equal to 2. Now let's do this. 2 to the second power is equal to 18x. 4 is equal to 18x. Divide both sides by 18. So 4 over 18, you guys. 2 could go into both. So 2 over 9 is equal to x. And if you plug that in, that looks to be good. Here, log log plus, so it's product rule. Log base 2 of, okay, x times x is x squared. X times 14 is 14x. Now, log to exponential form, 2 to the 5th is equal to x squared plus 14x. What is that? 4, 8, 16, 32 is equal to x squared plus 14x. Subtract 32 from both sides. 0 is equal to x squared plus 14x minus 32. Factor that out. So factors of this, you guys, is x is, x is plus 16 and x minus 2. So x is equal to negative 16 and 2. And if you guys look at your answers, x cannot be negative 16 because if you plug into there or there, it's going to give you a negative log. So no bueno. There you go. Last one for properties. All right. Log log minus sign, so it's quotient rule. So log base 9 of x minus 3 all over x is equal to 1. Log form to exponentials, so 9 to the first is equal to x minus 3 over x. Let's go ahead and multiply both sides by x so that we could cancel these off. 9x is equal to x minus 3. Subtract x from both sides. 8x equals negative 3. Divide both sides by 8. 8 is equal, x is equal to negative 3/8. And if we plug in negative 3/8 into there, it's not, we're going to have log of negative, so no solution. Alright, so that should be good practice for your guys' logs. Alright, so let's get into your guys' graphing. So, critical values, right? It's 1, 0, and b, 1. Our b value is this one, so it's going to be 3, 1. Now, let's look at your guys' transformations. Right 1 and down 2. So that means, I'll move this over here, when you guys make your transformations of these parent function coordinates, it's gonna go +1 for the right. Oh, there it goes. Ha. This is not good. I need to reconnect somehow, otherwise you guys are just looking at a blank screen. Let's see. Okay, looks promising. Yes. Okay. So +1, sorry, +1 for the right. Okay, if it goes down 2, that's when you guys subtract 2 from the y coordinates. So, in total, we're going to get 1 plus 1, which is 2. 0 minus 2 is -2. 3 plus 1 is 4. And 1 minus 2 is -1. Those are critical values. Now let's find the asymptote by setting that equal to 0. X is equal to 1. That's the vertical asymptote. So x is equal to 1. Let's plot our points. 2, -2. And 4, -1. Whoa. 2, -2, 4, -1, and we follow along and then curve. And there we go. There's your guys' graph. Alright, 10. So we got 1, 0. Your b value's right there. 6, 1. You always do 1, 0 and b, 1, you guys, okay? Alright, transformation time. Right 1 and up 5. So how does that affect the coordinates? Well, if it's right 1, you add 1 to the x. If it's up 5, you add 5 to the y coordinates. So we're going to get 2, 5 and 7, 6. Set this equal to 0 to get your asymptote. So vertical asymptote is x minus 1 is equal to 0. X is equal to 1. So again, graph it right here. 2, 5 is right there, and 7, 6 is right there. It's coming from down below, and curve, and there we go. Oh, sorry, I'm forgetting about the domain. Okay, so the domain of this one, you guys, is how far left is this graph going once you follow it along the curve. It's going all the way till there, so it's going to stop at it approaches the vertical asymptote, which is at 1 from the right hand side. And how far right does this graph go along the curve? It just keeps on going. So infinity range, you guys, for log functions are always -infinity to infinity. Alright, over here. Okay, again, domain. If you go all the way to the left, how far does it go? It stops right there. So that means your domain is, it approaches 1 from the right hand side all the way to infinity. Range is -infinity to infinity. Alright, 11. Okay, 1, 0, and b and our b value is this 4, so it's going to be 4, 1. Alright, transformations, left 3 and up 3. So left 3, you guys, right? That means we subtract 3 from the x coordinates, and up 3 is we add 3 to the y. So we're going to get -2, 3, and 1, 4. Make sure you guys get your vertical asymptote by setting it equal to 0. So x plus 3 equal to 0. Solve for that. X is equal to -3. So x equals -3 is your vertical asymptote. -2, 3 is right there. 1, 4 is right there. And this graph looks like it's coming from over there. Domain, how far left does this graph go? All the way till stops right there. So approaches 3 from the right hand side all the way to infinity. Your range is it's negative infinity to infinity. Number 12. 1 comma 0, our b comma 1, that's our b, so 4 comma 1. Let's look at our transformations. Right 1, right 1, and up 5. So if it goes right 1, you guys, right? You add 1 to the x coordinates. Going up 5, you add 5 to the y coordinates. So 2 comma 5 and 5 comma 6. Vertical asymptote. Set that equal to 0. So x minus 1 equals to 0. X is equal to 1. So x is equal to 1. 2 comma 5 is right there. 5 comma 6 is right there. Graph it along the vertical asymptote and then turn. Domain. How far left does this graph go? All the way to there. So domain approaches 1 from the right hand side all the way to infinity. Range negative infinity to infinity. 13. 1 comma 0. B comma 1, which is 3 comma 1. It goes right 1 and up 5. So add 1, add 1, add 5 to the y coordinate. So we're going to get 2 comma 5 and 4 comma 6. Vertical asymptote's right there. Set that equal to 0, so that's going to be x is equal to 1. So x is equal to 1, and we got 2 comma 5 and 4 comma 6 along the curve, and there we go. Domain. It approaches how far left does this graph go? All the way to right there. So approaches 1 from the right hand side to infinity. Range is negative infinity to infinity. And last problem, you guys. 1 comma 0. B comma 1. So our B value is right there. 5 comma 1. So it goes right 2 and up 3. So when it goes up right 2, you guys, you add 2 to the x coordinates. When it goes up 3, you add 3 to the y coordinates. 3 comma 3 and 7 comma 4. Vertical asymptote, set that equal to 0, so that's going to be when x is equal to 2. 3 comma 3 is right there. 7 comma 4 is right there. Guys, graph it along the curve and turn, and there you guys go. Domain approaches right there, which is 1. Or sorry, 2 from the right hand side all the way to infinity. Range is negative infinity to infinity. Alright, there you guys have it.